Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes, way. Don't delay and enroll now.
Geeks learning together.
So, hello everyone. Very good evening to everyone who has joined presently with me. So, can I please have a plus one in the chat box, those who have joined with me, so that I can very quickly start this session, and this will help me get to know your names as well. Yeah, I see quite a lot of people have joined in this session. So, please do a plus one in the chat box so that I could get to know your names, and I will be starting very quickly. Then, let's wait for a couple more minutes so that others could join. So I'm presenting my screen, and meanwhile, I would like to have a confirmation that I am properly audible and visible. Yeah, so yeah, I would request everyone to kindly do a plus one. Yeah, hello Yashwant, thank you very much. So Yashwant, so you are in your second year or your third year of your college. Would you like to mention that, or are you preparing for your upcoming interviews? Anything that would help me get to know you a little bit. I will be starting the session very quickly. I would request you all to kindly stay with me till the very end of the session. This session won't be very long, it will be around 35 minutes max, and we'll try to solve one very important question today. Names. Okay, so okay, Yashwant, you're in your third year. That's great. I am also in my third year. So I have already shared my screen. So can I please have a plus one that I am properly audible, visible, and everything is looking perfect so that I can very quickly start with the session today. Okay. So okay, let's start then. So would you prefer a white background or a black background? What do you think should be a good idea? Because in one of the session I was trying to use a black background, then someone mentioned to use white, and when I'm using a white background, then someone mentioned to use black. So which one do you think would be more appealing? Yeah, so anyone? Okay, white background works best. Okay, then let's move to white background then. Okay, so yeah, so Yashwant, is this your very first session today with me? Okay, then, very well. Let us continue with our session. Before I start, let me give you a small introduction about this session. So, this session is called Practice Session for SDE Interviews. Okay, so on this session, what happens here is that every week I pick up a topic and then I discuss questions, one or two questions on it every week. Okay, so today we are discussing dynamic programming, and today we will be specifically discussing questions related to stocks. Okay, so there is a special type of problem called DP on stocks. So we will be trying to solve one or two questions from this particular topic. And previously we did about DP on subsequences, DP on substrings. We also did about 1D DP, 2D DP. We covered these topics in the previous sessions. We initially started with binary search, then we moved towards maths, stacks, queues, and then we are currently doing DP. Then we will also be doing graphs and trees as well. So particularly if you are just thorough with this entire series, you will get to know some important questions which are very frequently asked. Okay, on interviews. Apart from that, let me give you my introduction. Okay, so just like Yashwant, I would request all of you all to kindly do a +1 in the chat box or just interact with me so that we can, so that this session becomes interactive and fruitful for both of us. Okay, so let me give you a small introduction about myself. My name is Gaurav Kumar Shaw. In case if you are looking to connect with me, you can search this exact name on LinkedIn as well. You will be able to find me. And I am presently in my third year at IIT Kharagpur. Okay, and I'm also a mentor at Geeks4Geeks. Okay, so this is about me. You can find me on LinkedIn by the same name, and if you would like to get connected with me. Okay, so let us begin with our session for today. And Yashwant, do you have any questions to ask or anything else you would like to say? Or apart from that, do you have do you already know about dynamic programming? Have you solved questions related to dynamic programming? You are familiar with the concept? Okay, so I will be discussing. Let me choose a question for today, and then I will be starting with the session. Okay. Okay, so let us continue with our discussion. The question is DP on stocks. DP on stocks 3. Okay, so let's see. So what is happening here is that you are given an array, ARR, okay, of length n, and in this particular array, it represents the price of stocks on n days. So this n is basically representing the number of days, and this array is containing the price of stocks on those n days. Okay, so you are given this information in the form of an array. Now, what you can do basically is that you can buy and sell this stock any number of times. Okay, so first point is buy and sell stock any number of times. Okay, now and you can't buy a stock again after buying it once. In other words, we first buy a stock and then sell it. After selling, we can buy this and sell again, but we can't buy this and sell the same stock which we have previously bought. So it means that every stock you can buy once. Okay, and if you're deciding to sell it, it means that you can no longer buy because you can only buy your stock once. So let's say there are stock A, stock B, stock C, stock D. So basically, this is the stock, and the prices on the 4 days are A, B, C, and D. So let's say you bought at price A, and then you sold at price B. Okay, so you just completed one transaction. Okay. Hmm. So basically, what is happening here? Once you sell the stock, then only you can buy the stock once again. Otherwise, you will not be able to buy. So it will happen something like that. You buy a stock, you then sell a stock. You then buy a stock and you then sell a stock. Okay, it will not happen something like this. You buy a stock, you again buy a stock. Okay, you cannot do that. Only one unit of stock is only available for purchase. You can only buy a stock and then sell to again buy. Now the entire motivation of this problem is to maximize the profit earned. Okay. Hmm. Okay, so the entire motive is to maximize the total profit that you can make by buying and selling the stock. So you have to profit. So that you have to maximize the profits. Okay. So tell me, how will you do it? Any ideas, anyone? I see quite a lot of people live with me presently. Could you please do a +1 in the chat box and at the same time, yeah, like this session that is being streamed as well. Okay, so this will help to keep this session interactive, and you all can write in the chat box what are your approaches, how we will solve this. First, most importantly, if anyone can answer, how is the concept of dynamic programming being applied here, and why not a greedy strategy will work. Okay, so anyone would like to try it out and tell me why exactly the dynamic programming strategy working and not greedy? Okay, anyone out there? I will be discussing solution in just a couple more minutes, but before that, it would be really great if you could answer, if you would just even try out in the comment section. Yashwant, are you there? And those who have joined me, I would request you all to kindly stay with me till the very end. The session won't be very long. It will be around 35 minutes only. Okay. Anyone? Yashwant, are you there? Okay, then. Let me continue with my discussion then. So, the solution idea will be something like this. I'm sure everyone has understood the question. Now, let me discuss solution idea. So, basically, the solution idea is based upon this fact that every day you will have two choices. So, every day that you will have two choices, whether to buy or whether to buy a stock or do nothing. So, the choices are you buy a stock or do nothing. Okay, and move to the next day. After you make this, you move to the next day. And when you move to the next day, if you have already bought the stock, in that case, your only choice would be to sell the stock. And if you would have done nothing, then again you have two choices to either buy a stock. Hmm. Hmm. So let me just draw this once again. So probably next day you have got two options again. So for every, let's say you have bought the stock. In that case, you can either sell the stock or you do nothing. Okay. And let's say if you have already done nothing, in that case you can just you again have two options, either to buy the stock or do nothing. Okay. So it means that every for every any given day you have two choices, whether to buy or do nothing. And for each of the choices that you are taking, you again have two choices. Where if you are buying, you can either sell or you can do nothing. If you are doing nothing, you can either buy or do nothing. Okay. So if you can observe it very carefully, this part of the recursion and this part of the recursion are basically same, but this part is a bit different. In this case, you are selling, but in this case, you are buying. You have to make sure that whatever path you are going in, you have to supply that information to this part. Okay. So if you're buying it, you have to basically send an indication that you have bought the stock, so it's time to sell. So this is one of the ideas that we can derive from the problem solution setup. Okay. So now what will be a profit? So you can only make a profit if you are right, if you will sell a stock. Profit can only be made if you are selling a stock. Okay, it means that you already bought a stock and then you sold a stock. So the profit will be the difference in the amount. Okay, so sell minus buy. This will be the profit. Now you have to basically sum up this entire value across all possible choices. Okay, all possible choices. Okay, and then you have to basically find the maximum of this particular answer. Now the thing here is that since we are requiring all possible choices, it means that since there are n number of days, the complexity will be 2 to the power n, because for every day we have two choices, and for every choice we are making, we again have two choices. So basically the time complexity will be exponential in this case. So in order to decrease the time complexity, we will be utilizing the concept of dynamic programming. Okay. So this is where we solve this problem. So the first step is to write a brute force recursion. Demonstrating this entire problem. Okay. So now what do we have to do is write a brute force recursion. Okay. So let's see. Let's try to write a brute force recursion. I hope this part is clear with everyone. Can I please have a +1 in the chat box if it is clear with you all? I see quite a lot of people in the live streaming session, but you guys are not interacting with me in the chat box. I would highly encourage you to kindly interact with me in the chat box. That will help me deliver good quality content to you as well, and it will keep my morale high. Okay. So, anyone would like to answer how exactly we can construct a brute force recursion to solve this question? So basically, we have to find all possible solution. That is the entire reason we are using dynamic programming to solve this question. Okay. So yeah. So there is a course called Complete Interview Preparation. I would like to give you a small announcement meanwhile before we start discussing with the question. So at Geeks for Geeks, we have a course called CIP course. So it is an extremely famous course, and it is one of the best-selling course at GFG. So basically, this is complete interview preparation. Okay. So this course is basically complete interview preparation. This is an extremely well-structured course if you are preparing for your interview. So it contains all the most important topics and concepts and the questions which are frequently asked in interviews these days. And if you are in your second year or if you are in your third year, definitely do check out this course because it will most certainly be helpful for your interview preparation. Something which you can cover in 2 months time, and that will help you basically get a edge in interviews than your other competitors. Okay, so definitely try to check this course out. Okay, so that's about the course. Now let us move to the brute force recursion part. Okay, so as I've already mentioned about the solution idea that we can try to optimize. So the idea is to write a brute force solution. Okay, let's have a look here. Hmm. So first of all, let's say that I have a function called int solve. Okay, so this function is basically accepting a vector called prices, which will contain, it has n prices for n days. This is a vector, and it contains the prices for the stock for n days, and the total number of days is n basically. So let's say I accept these two functions. Now what I can do basically is that I have to declare a recursive function. Okay, so this is the function that I have received from the input. Okay, so what I can do basically, I can declare a recursive function, and let me just write something like this int f, and let me send the vector prices. Okay, and let's see what else can we send here. Okay, so now this is basically the caller function. Now I am trying to declare a brute force recursion. So first of all, what are the values that we need? The first value that we need is the array of the prices. Okay, which is basically this exact value only. After that, we also need the total number of days. So in that case, it will be int 10, which is basically this value. Apart from that, what else do we need? Now let's say we are standing on day number one. So we need an index also. Okay, index will basically denote on which day you are presently trying to make a transaction on. Either you buy or sell or do nothing. Now we also need an indicator that whether we have bought a stock or not. Okay, so what exactly is this indicator? So this indicator will be 0 if you have not bought a stock, and if this will become 1 if you have bought a stock. So why is this indicator necessary? Can anyone tell me? Can anyone tell me why exactly do we need an indicator in the form of a variable called y that will help me solve this question? Yashwant, can you tell me why do we need an indicator for specifically for this purpose to know that whether we have bought the stock or not? Anyone? Can anyone tell me why do we need an indicator? Okay, so let me tell you the answer. So as I just mentioned that, let me give you the recursion diagram. So this was a recursion diagram. Okay, so the recursion diagram was something like this, that for every day you have got two choices. Now the choice can be that you try to buy a stock or you do nothing. But if you're buying a stock, then in that case you cannot buy a stock anymore. You have to sell that stock first, then only you can buy at a different day. So that is the reason we need an indicator to know that whether we have bought a stock or not. If you have bought a stock, then we can only sell it. But if you have not bought a stock, in that case we can either buy the stock or do nothing. So that is the reason we need an indicator of whether we have bought a stock or not. Now let's say that we have this is an indicator for that purpose. The next value that we need is that what is the next value that we need? Int cap. And what exactly is this value doing? I will tell you something sometime. Okay. So these are the values that we need to solve this question. Okay. Now, what exactly is the will be the conditions for my recurrence relation? Anyone? Can anyone tell me what are the recurrence relation conditions that we should follow? Okay, for do nothing. Okay, Yashwant, you're correct, sir. Hello, Funwell, how are you? Can you please write in the chat box in which year of your college are you right now, and are you preparing for your upcoming interviews? Okay. So now let us look into this value. So basically, if buy is equal to 0, it means that we have not bought anything. So it means that I can buy a thing or do nothing. So I have to declare a variable called profit, and my profit will be something like this. Profit is equal to, I have got two options. Now my two options will be something like this. Since I first of all I decide to not buy a stock. Okay. So let's say if I am buying a stock, so first of all, what exactly will be my profit? For example, let's say my profit is X rupee and I'm trying to buy a stock. In that case, what I'm doing basically is that I am spending that much amount into the stock. Okay, I'm not getting that stock. If I'm selling that particular stock, in that case, I'm receiving the money. But buying the stock is basically giving away the money. So if I'm buying the stock, it means that I have to spend negative amount of money to buy the stock. And if I'm selling the stock, it means that I will be receiving positive amount of money. Okay. So profit will be of maximum value of the two cases. Okay. Now there are two particular cases. The first is that I am doing nothing. If I am doing nothing, I will add 0 to my profit because I did nothing, and I move to the next index. Okay. So next index array will be array, n will be n. Now this will become index plus 1. Okay. Now since I have not bought anything, in that case, what will I do? I will basically send 0. Okay. 0 means I have not done anything. Buy is still 0. Okay. Buy is 0 means I have not bought the stock yet, and in this first function I did not buy the stock as well. So buy is 0, cap will remain the same, and yeah, so these are the functions. After that, there is another value. Let's say if I decide to buy the stock, if I'm deciding to buy the stock, in that case what I will do minus of arr of index. Okay, then I will again call the function f, and this time I will again send the array n, index plus 1. Okay, index plus 1, and then this will be again 0 because I bought a stock, right? Okay, since I have bought a stock, in that case the buy will be 1. Okay, so in this case the second condition, the buy will become 1. Okay, and what do you think will be cap? Cap will be the same thing. Okay, why, what exactly is cap? Can anyone tell me what exactly is a cap variable? Okay. Okay, int cap. Okay, so in the question, cap is basically the total number of transaction allowed. Okay, but in the question, we have already mentioned that we can make any amount of transaction. So let me just write here. Cap is basically the total number of transaction allowed. So once you're buying a stock and then you sell a particular stock, this includes one transaction. Okay. Now, the value of cap indicates the total number of transaction you can make. But in the question, it is already mentioned that you can make any number of transaction without there are no restriction. So basically, what is happening here in this question, we do not need anything as cap. Okay. Hmm. Cap. Okay. 1 minute. Hmm. Okay. Yeah. So there is a one more requirement in the question. The question says that you can make at most 2 transactions. Okay. So let me just get to the problem statement that we discussed here. Yeah. So this was a problem statement that we discussed. So basically, you can buy and sell the stock any amount of any number of times, but you can only make 2 transactions. Okay, which means that you bought a stock, you sold a stock, you bought a stock, you sold a stock. This is the only type of transaction you can make. Only 2 transactions. That is the reason we are calling it DP on stocks 3. Okay, so this is a slightly special variation of a similar question. So that is the reason we are needing the value of stock. That is the value of cap. Okay. So in that case, what will happen here? We have to keep a value int cap. Okay. Now, once every time we are completing a transaction, we have to basically decrease the value of cap by cap by 1. So initially, what we are doing, let me just put the value here, right? Okay. Okay. So initially, what we are doing is that, let's say that the prices. So the value of n will be n. The value of index will be equal to 0. Okay. So value of index will be equal to 0. Hmm. And also the buy will also be equal to 0. Cap will be equal to 2. Okay, cap will be equal to 2. So every time we are completing a transaction, we will decrease the value of cap by 1. Okay. But if buy is equal to 0, it means that we haven't yet completed a transaction. So in that case, I won't be doing, the cap will remain same in both cases. Okay, so in this case also cap will remain same. Now if buy is equal to 1, okay, if buy is equal to 0, then we do this. But let's say if buy is equal to 1, in that case what we can do? Okay, so if buy is equal to 1, so I hope everyone understood about the importance of cap here. So do you have any doubt? Yashwant, did you understood that what exactly we are doing with the variable cap here? So anyone? Yeah, complete of buy and sell means 1 transaction, and the question it is being specified that you can only make 2 transactions. Okay, so that is the reason we are utilizing the value of cap. The thing here is that if buy is equal to 0, it means that we haven't yet bought any stock. So the value of cap will remain same for both the cases. Now the thing is that when buy is equal to 1, it means that we have already bought a stock. Now it's time to sell the stock or do nothing. Okay, so now it's time to sell the stock or do nothing. So let's say in this case also profit will be a maximum of 2 values. The profit will be maximum of 2 cases. The first case is that we try to do nothing. In that case, what we will do? 0 plus f of ARR n int plus 1. Okay, 1 cap. Okay, so this is basically we did nothing. But now let's say I sell the stock. So since I'm selling the stock, the profit will become positive because once I sell a particular stock, I get an amount to me which I can add to my profit. So if I'm buying a stock, I subtract that amount from my profit. If I'm selling the stock, I add that amount to my profit. So basically, what is happening? The difference of the buying and sell is finally added to my profit. So that is the reason I will be doing error of plus this. Now I will write f, which is basically the sum, the function that I'm trying to call, and in this case also index will become index plus 1. Now since I've already sold the stock, in this case again I will do, my buy will become 0 because I have already sold the stock and my transaction is complete. So if my transaction is complete, my cap will decrease by 1. Okay, so this is the entire idea. Now we also have to think about the base cases of the recursion. Okay. Now finally we will be returning the value profit. Okay. We will be returning profit. Now we have to think about the base cases as well. What will be the base case for this recursion? Can anyone tell me? Okay, so let me rub this part and I will be utilizing to write the base cases here. Okay. So let me just yeah. So let me write the base cases with red pen. Okay. So tell me, what will be the base cases? Anyone? Hello, Yashwant. Can you tell me what exactly do you think will be the base case? Yeah. So the base cases will be something like this. If int is equal to n, it means that you have already completed your or cap is equal to 0. Either you have exhausted your array, array of the prices, or your cap is equal to 0, which means that either end days are over or your number of transactions are over. In that case, you will return 0 because there is nothing you can do. Okay, so this will be the only base case. Now, can anyone tell me what will be the time complexity of this approach? Okay, int n basically means that you are already given an array which will contain the prices of the stocks on n particular days. Okay, and once you basically complete those n days, it means that you have already exhausted your prices array and all the n days are over. So it means that you can no longer buy or sell a stock. So your profit, you will add a zero value to your profit, right? So if you just exhaust your values, in that case, you are basically adding zero. Ganesh, did you understand this concept? Okay, so can anyone tell me the time complexity and the space complexity for this approach? The time and space complexity for this approach will be exponential because I have not yet utilized the dynamic programming array. So what you can basically do here is that you can declare a DP table, a 2D DP table of the size of the DP table will be something like this. It will contain three DP table. Okay, so the first will be index. The second will be whether you are buying or selling or not. So buy or sell, or third will be cap. So n into 2 into 3. So 6n will be the size of the DP table. So what you can basically do is that once you are returning the value of the profit, so this function has three variables. Okay. So what you can do basically, profit is equal to, so dp of index cap and index by or cap. Okay. So you can just put index by and cap. This is equal to profit. Okay, and then you return this value, and every time you enter into the recursion, you just check that whether this particular value is equal to -1 or not. Okay, so dp of index comma cap comma index comma cap comma or index comma by comma cap. Okay, so it is equal to index comma by comma cap is not equal to -1. You return -1. In that case, you will return this particular value only. Okay, so dp of all the values. So this will be the base case. This will be the basically the dynamic programming optimization that you can make to decrease the time complexity. So initially it was exponential. After we apply the concept of dynamic programming, it becomes quadratic in nature. Okay, so let me write the dynamic programming approach. Okay, so once I applied the concept of dynamic programming, the time complexity decreases to big O of n into 2 into 3. So why we are having this 2? Because it can either be 0 or 1. Okay, it means that you are buying a stock or you are not buying a stock. Okay, so basically, hmm. And what will be the value of cap? This is basically for the value of cap. Now cap can be the 0, it can be the 1, or it can be the 2. Okay, so 2 means that you have not done any transaction, 1 means that you have done one transaction, and 0 means you have already completed 2 transactions. So cap is taking 3 values, so that is the reason we have 3. By variable is taking 2 values, it can either be 0 or it can either be 1. That is the reason we are taking 2, and n is the total number of days in the stock. Okay, so the time complexity is n into 2 into 3. Now what will be the space complexity? Can anyone tell me the space complexity for this problem? Ganesh, did you understand the concept about returning 0? And meanwhile, can anyone tell me what will be the time and space complexity for this problem? Hello, Yashwant. Okay, so the space complexity will be first you have to ask yourself a question that what are the spaces that you are taking. So you are taking a DP table. Okay, now you are taking a DP table plus you are utilizing the concept of recursion. So a recursion stack space will also be there. So the size of the DP table will be n into 2 into 3. Okay, because you are declaring a 3D DP table of 1 is n, then is 2, and then is 3. Okay, so this will be the size space complexity because of the DP table. Now you are also declaring recursion stack space also. The stack space will be n. Okay, because there are n days and at max you can have n types of n, the recursion depth can be of size n. So that is the reason this will be the time complexity. But it is quite better than exponential time complexity of 2 to the power n, which you do not want. Okay, so I hope everyone understood about this concept. Okay, thank you, Ganesh. You are welcome. Okay, so Yashwant, did you understood about the concept of DP optimization and at the same time the time and space complexity of this problem? So if you have any doubts, you can ask me in the chat box, or we can wrap up our today's session. We will be again meeting next week with dynamic programming questions. Hello, Vishnu Vardhan. We have started our session on 9 p.m. and we have almost reached the end of our session. So I hope I could see you on next session. So let me give you a small introduction about this session for those who have joined late. So this particular session is practice session for SDE interviews, and in this session I take up a question, I take up a topic every week, and we discuss one or two questions related to those particular topics on the day of our session. So this is usually on the days of Monday to Wednesday. Okay, okay, Yashwant, I'm explaining. So yeah. So apart from that, we also have a course called Complete Interview Preparation on Geeks for Geeks. And if you are a student who will be having their upcoming internship and placements interview, you can definitely check out that particular course because it is an extremely well structured course which will definitely help you in your interview preparations. Okay, thank you, Vardhan, very much. So Yashwant was asking about space complexity. So Yashwant, what is basically happening here is that you can see my full screen. So I have already written. So I have already written something called as space complexity is n into 2 into 3. So basically it means that you have to first think of all the spaces that you are occupying in your program. So you are occupying the concept of you are utilizing the space in the form of the DP table. Okay. So since you're utilizing the DP table and the size of the DP table is n into 2 into 3. Okay. So that is the reason you have a space complexity of that particular value. And apart from that, since you are utilizing the concept of recursion also, the recursion is also taking a stack space because every time you make a recursion call, it takes up some particular amount of space in the computer memory. So that is the reason we have to utilize we have to include the recursion stack space as well. So that is the reason we are having space complexity of big O of n into 6 plus O of n, which is actually much better than better than exponential time complexity. Okay, so I hope Yashwant, you have understood the concept. So yes, Vardhan, lead code and Geeks for Geeks are enough for lot of interview preparations. Okay, you can follow Striver Sheet or Interview Bit as well. That will also help you. But on GFG, you can also see a SDE sheet that contains all the important questions that will most certainly be helpful for you. Okay. So yeah. So do you guys have any question? Okay, then we meet again next week, Monday to Wednesday, and we will try to complete dynamic programming and start with graphs in the next week. Okay. See you then. Bye bye.